I wanted to take a moment to talk about how you can identify some common clastic sedimentary rocks, or another word we use for clastic is detrital. It just means that it's made of pieces of other rocks that have broken down. They've been compacted and cemented, we call that lithified, together, and then form a new rock. So kind of a new rock out of some old bits and pieces of things. And so we're going to talk about a couple different things. The first thing is grain size. And so we get things like gravel, which are coarse grained, sand, which is kind of a medium grain, and then we get silt and clay, which we lump together and called mud, and that's going to be our fine grained. So let's take a look at that first. So if I look at my 5 really common clastic sedimentary rocks, we'll see that our conglomerate and breccia are both made of our really coarse grain. So these are going to be made of gravel. So if you have gravel in your rock, you probably have either conglomerate or breccia. Sandstone, as the name implies, is made of sand, and sand is very gritty to the touch, but not big enough to be gravel. So here we go. Sand is what our sandstone's made out of. And your lab manual will talk about how gravel is anything over 2 millimeters, which is something you can definitely visually see. And then finally, our mudstone and shale is going to be made out of mud, so silt and clay. And so for these, mud is going to be something that feels very smooth. So it's fine enough to where you don't feel the grit of sand anymore. Okay. So we have gravel, sand, and mud. So it's the first thing to be able to lump these into the right kind of area. So now let's talk about sorting. And so sorting has to deal with the variation in grain sizes in a given rock. And so if something is well sorted, it's like well sorted laundry where like you have all your whites together and all your colors together, something like that. And so this well sorted means you've got all of your small stuff together or all of your big stuff together. Poorly sorted is like the laundry hamper where everything is all mixed together. And so you'd have grain sizes of all sorts. And so our conglomerate and breccia are going to be like our hamper, where it's just a mix of everything. Because it has gravel, has the large stuff, it tends to have a lot of small things too. It's really uncommon to have just gravel sorted out. And so what we would add to this is that our conglomerate and breccia are going to be poorly sorted. Okay, so conglomerate breccia are poorly sorted. They have gravel all the way down to mud usually. And then that brings us, we're going to go to the other end member, which is our mudstone and our shale. By definition, because it's all mud, it has to be well sorted. It's like sorting our whites out of the laundry. So this is going to be well sorted. Now, sandstone's kind of a weird one because even though it's all sand size, we have coarse sand all the way down to fine sand. So we could call it well sorted if it's either all fine sand or all coarse sand, or we call it poorly sorted if it's a mix of all sorts. It seems like a weird distinction to make, but it does actually make a difference for reasons we won't talk about here. So sand can be either, or our sandstone can be either. Okay, so that's fine. We have all these options kind of there, but we really didn't talk about how to differentiate between a conglomerate and breccia and how to differentiate between a mudstone and shale. So let's look at conglomerate and breccia. And this goes to our final concept in kind of how we classify grains, and that's the rounding. And so some of the grains are very rounded, like think river rock, nice and smooth, and then other grains are very angular. And so our conglomerate is actually a sign that water has come over and washed over those particles. So they are rounded. So these would be rounded grains. And then our breccia is the opposite of that, and those are going to be angular. So breccias can form in something like a landslide where everything just gets jumbled up and crushed up into these angular pieces. Now, one important thing is when we talk about rounded versus angular, we're not talking about the shape of the rock. I can take any rock and I can build it into a cube, and then that will be considered angular, right? Or I can smooth it out and it'll be considered rounded. What we want to know is the shape of the particles inside the rock. So if we were to take, here's my conglomerate or breccia, the shape of the rock doesn't really matter. We want to know, are the particles inside smooth or are the particles inside they have jagged edges. So if the particles inside are jagged, it's a breccia. They're smooth, it's a conglomerate. The last one is between mudstone and shale. So they're both mud-sized particles. But in the case of a mudstone, it really is what we call just like blocky. So it'll break off into like fist-sized chunks or smaller chunks, but they're kind of irregular in shape. And that's because the little mud grains are kind of all in different directions. They're just stacked up like that. With our shale, what's happened is these mud grains are actually like flat little plates. And so with the shale, what the plates have kind of aligned themselves, something like this. So when shale breaks, it actually does break into kind of flat tablets. So think of like a book, right? So we're looking at the side of the book. These are the pages of the book that are kind of sticking out there. And then you'd have a flat surface on top, which would be the cover and the back cover of the book. So top and bottom surface. So our shale is kind of this book-like tablet sort of arrangement. Our mudstone is more blocky. This kind of book-like tablet feel to it, we call that fissile. Oops. It's like missile, but with an F. Fissile or fissile. All right, so hopefully that helps differentiate those things, and really remember to think about that rounding inside the rock, not the rock itself, but the grains inside. That's really going to help you.